I'd like to discuss percent yield. Percent yield is very important in chemistry, especially in like pharmaceutical companies, where a pharmaceutical company is paying a lot of money for the reactants that they're going to be using to make whatever drugs or compounds, chemicals they're trying to make, like maybe aspirin or something, and they want to get as high of a percent yield as possible. Percent yield is calculated pretty simply. All it is what do you actually get from, like, we'll call it the experiment. How much product do you make actually in the lab, in the experiment, when you actually do the reaction, over how much theoretically you should be able to make. Now, how do we figure out how much theoretically we should be able to make? Well, that is from stoichiometry. We should be able to know theoretically how much we can make from stoichiometry problems. But when you do it in the lab, you don't actually get what stoichiometry says you should get. You always get something a little bit less. We don't have the right conditions. There's just certain things, and we lose some. We don't get exactly what we are predicting we want. So we take this times 100, and we have what we call a percent yield. Of course, we want this to be as close to 100% as possible. The more it's close to 100%, the less money we're losing in what we're in the reactants that we have to buy. So let's just do a simple stoichiometry problem and kind of assign a percent yield to it. Let's say that we are just with the most simplified reaction that we know. We're going to make some water, and of course we do that with hydrogen gas and oxygen gas. We've seen this a lot, and we make water, and we get the balanced recipe. Of course, it would be 2 parts hydrogen for every 1 part oxygen. And let's say that we're going to make some water, and we're going to use 7 grams of oxygen gas in our reaction. Don't worry about how much hydrogen gas. Let's say we have an excess of hydrogen gas. So we got plenty of that. So I want to react all 7 grams of oxygen. I want to see how much water I theoretically should be able to produce. Now let's just keep in mind, let's up here on the side here, let's say that in the lab, when we actually did this reaction and we reacted 7 grams of oxygen, let's just say that we end up producing 7.5 grams of water. In the lab, that's how much water we actually produced. Okay, so that's our experimental production of water. Well, what we want to do is we want to do a stoichiometry problem to figure out how much water should we have been able to make. And so we will start with our given 7 grams of oxygen. And of course, to do a recipe, we need to convert that to moles. So 1 mole of oxygen's diatomic is 32 grams. And so grams of oxygen cancel out. And now I can put in my ratio of oxygen to water. And it's 1 mole of oxygen to every 2 moles of water. That's what the recipe calls for. And now I can convert that back to grams. So 1 mole of water, by now you know, is 18 grams. And my moles of water cancel off. And if I do this workout, I take 7 times 2 times 18 and divide by 32. I will end up with an answer of about 7.9 grams. So that's how much water I should actually have been able to make if I used 7 grams of oxygen and I had excess hydrogen, 7.9 grams. But you'll notice in the lab I only made 7.5, which is reasonable. I mean, you're not going to be able to make 7.9 grams. You're not going to be able to get to 100% yield. That's basically impossible. You can come really close. So what was my percent yield for this lab experiment? Well, it'd be 7.5 is how much I made in the lab, divided by 7.9 is what stoichiometry told me I should have been able to make, and I could take that times 100, and I get around 95% yield, which is pretty good. 95% yield. I yielded 95% of what stoichiometry told me that I probably should have been able to yield. So percent yield is a nice calculation to show the efficiency, how well your reaction turned out.